Suppose you wanted to generate 3 random numbers and then print them to the screen formatted like this, so with commas and an and here in between the list of numbers. Well, you'd probably write code something like this. So you would have, first of all, you would generate the numbers themselves, and then you would do a call to disp here to display them, and you would build up the string using num to string and string concatenation with the square brackets. The problem with doing it like this is that this sort of code can get quite hard to read, especially if the string is long or the code that generates these numbers is quite long in here. So this can get difficult to follow and difficult to read what's actually going on. So there is an alternate way that you can do it. So I'm just going to show you that's using a function called fprintf. So what I'm going to do is just type out how you would use it, and then I will explain what each of the pieces mean. So let's run that, satisfy you that it's actually doing the same thing. So you see the same thing was printed twice, once from my call to disp and secondly from my call to fprintf here. So let's explain what each of the pieces are. The first argument in the call to fprintf is called the format string. And so this is the string which is going to be printed with some placeholders where you're going to place some values. So the placeholders here begin with a %, and then they have a character after the %, which indicates the type of data which is to be printed. So the I in this case stands for integer. So what that means is that the numbers will be printed without any decimal points, so just a straight integer number. So you can place these placeholders wherever you like within the string, and so fprintf will simply read through this string, and when it comes to the first placeholder, then it will look over here to these remaining arguments and grab the first one and format that as a string according to the requirements of this format specifier and place that value in here replacing this placeholder, and then it will proceed through the string until it reaches the second one, and then it will grab the second argument and process that, and then the third one, and finally the third argument. So the other thing which is in here is this /n at the end, and so what that means is go to a new line. So display here automatically puts a new line at the end of your string for you, but fprintf is a little bit more flexible and allows you to actually have strings that don't necessarily jump to a new line, or perhaps to have multiple new lines inside your string. And so the way that you specify a new line is with a / and then n, and so those are called escape characters, and there's a table of them in the documentation for fprintf. So let's look that up. fprintf. So writes data to text files, so you can use fprintf for writing out to files as well as printing to the screen. If you want to print to a screen, then you actually use the second syntax, which is the one that you see here, and so that's the example which I just gave you is using this syntax. So we have a format string and then the values which are to be formatted. So here is the the help file for the format string, and so there's a few things here which you can read about. So the escape characters, here is the list of escape characters which you can use. So you've already seen /n for new line. There are others, you can read them here. And then there are the format or the character conversion specifiers themselves, which begin with a % and then have this sort of structure. So let me just give you a few examples of some common types of structures which you might want to use. So a common thing is you want to print out a decimal number, and so you would use %f for floating point. So if I actually run this code, then the number pi gets printed out using so many decimal places. It defaults to, looks like 6. If I want to change the number of decimal places, then I put a dot here before the f, and then I put the number of decimal places which I want. So if I wanted 3 decimal places, then I would put a dot and then a 3. And so now you see a number was printed out using only 3 decimal places. If I wanted more, say I wanted 10, I put a 10 there, and now I get it printed using 10 decimal places. And so that's a convenient way to control the precision to which you're printing your numbers. So there's another format which is quite useful, and this is %g. And so if I have a small number, let's say 12, when I print that, it will be printed simply as 12. But if I had a very large number, then it will be printed using scientific notation. And so the meaning here of this lowercase e is 10 to the power of. So this would be 1.2 times 10 to the power of 9. And so that's a convenient thing if the size of your numbers varies greatly. If you want them to be printed using standard decimal notation for small numbers, then you can use G, but if you want it to be using or to automatically switch to scientific notation when the numbers get big, then that's what that %G format specifier will do for you. There's a close variant to the fprintf function which is called sprintf. So what sprintf will do is return a string rather than print it to the screen. So we could use it like this. And so what that will do is generate a variable called message, which is a string, which contains the formatted text. And so there's another format string which we should introduce to you, which is %s, and that stands for a string. And so you can actually use that to join strings into another string. So for example, if we wanted to enclose it in quotes, we could do that. And so you put %s there, stands for string, and so then the corresponding data item over here will be placed into the string in that location, like so. So a good example of using sprintf is if you're formatting a figure. So let's say you wanted to generate the title for some graph. Let's just bring up an empty figure. You wanted to generate the title from formatting some string. So you might have case number %I, and then that might come from somewhere. Let's just put the number 10 in there for now, but that would obviously in a real situation be some actual variable, maybe the counter in a for loop or something like that. And so we could run code like that, and what happens is that the sprintf function returns the string, and that string gets passed to the title function. And so you can use that sort of thing anywhere where you need a string, so in figure titles and axes labels, even in legends. So legends are a good example of where quite often you want to build up a string from inside a for loop by formatting a string, and so this is an elegant way to do that, particularly if you want to control the number of decimal points which you use, for example using the %f formatter. One final thing that I wanted to show you is how you can use the fprintf function to actually write data out to a text file. So the first example of syntax here is how you would do that, and there's actually an example further down in the file, so I'll just scroll down and find that. And so that's this example here. So if you wanted to write out your formatted strings into a file called exp.txt, then this is the code of how you would do it. So you first open the file, a function called fopen, and then the W here means that you want to write to the file. So you need to specify whether you want to read or write at the time at which you open the file. So open the file for writing, and then you get back a thing called a file ID, which is just a number that the computer uses to refer to the open file. So then you make your call to fprintf and you pass in the file ID as the first argument here, and then use the function as per normal. And then when you're finished, you close the file with fclose. So that's a brief little example of how you can use fprintf function to actually write out data to a text file.